In Unit 6, we're going to take a look at circles. We'll start with some vocabulary. In this first box, this is a central angle, an angle whose vertex is at the center of the circle. And it states that the measure of the angle ABC is equal to the measure of the arc AC. That's your central angle. In the next box, this is an inscribed angle. And an inscribed angle is equal to half the measure of the arc. So it's saying that the measure of ABC, this angle, is equal to half the measure of this arc. In this next box, it takes a look at overlapping arcs. So the measure of angle ABD, that's this guy highlighted in red, equals the measure of angle ACD, that's this guy highlighted in purple, because they intersect the same arc. So their measures are the same. In this next box, we'll take a look at inscribed quadrilaterals. A quadrilateral, of course, is a four-sided figure. When it is inscribed, that means it is inside the circle, opposite angles are supplementary. So the measure of angle A plus the measure of angle C equal 180, while the measure of angle B plus the measure of angle D equal 180. Intersecting chords or secants on the interior. Alright, so if we intersect inside the circle, and a chord is going to be a segment that has its endpoints on the circle, a secant is going to go through the circle. The measure of angle 1, which is this angle right here, is half the sum of the measure of the arcs. So if I take the measure of arc AB in blue, add it to arc CD, and multiply it by a half, I'll get the measure of this angle. Likewise, if I take the measure of arc AC, add it to arc BD, multiply by a half, I'll get the measure of angle 2. Intersecting tangents and chords on the circle. So this time their intersection is on the circumference. Angle 1 is equal to half of this arc. That's what this first statement is saying. If I take a look at the other one, measure of angle 2, that's this angle here, is equal to half the measure of this arc, AC. Intersecting secants on the exterior. That means they're crossing outside the circle. This is a secant BD, and this is a secant CE. They intersect outside of the circle. And what this says is the measure of the angle is equal to half the difference of these arcs. So you take this first, the bigger arc, DE, and you subtract the smaller arc, BC, you take half of it, and it's equal to the angle on the outside. Intersecting secants and tangents on the exterior. So a tangent line is only going to touch the circle once. AB is a tangent line. CD, this is a secant line because it's intersecting twice. And it says that the angle on the exterior, angle A, is half of the difference of those arcs. So BD minus BC, multiply by a half, that's equal to that exterior angle. Intersecting tangents. So again, tangents only intersect once. AB is a tangent to this circle. AC is also a tangent to this circle. Angle A is equal to half the difference of the arcs. Take the big arc, BDC, subtract the smaller arc, multiply by a half, and you'll get the exterior angle. Segment lengths in circle. If AB is a tangent, that means it's only intersecting once, to a circle C, then AB is perpendicular to CD. Two tangents from the same external point. This point B, AB is a tangent line, BC is a tangent line. If AB and BC are tangents to the circle, then they are equal in length. AB is equal to BC. Intersecting chords or secants on the interior. All right, so now we're going to take a look at chords. Chords stop on the circumference. So this chord here, highlighted in the two different blues, has its endpoints on the circle. The same with the chord AB. It also has its endpoints on the circle. And what this is saying is that if you take the length of A, multiply by the length of B, so this guy in pink times this guy in purple, that equals the product by multiplying this piece in blue, C, times this piece in dark blue, D. Intersecting secants on the exterior. So here's a secant. It's intersecting twice. And this segment here is also a secant. It's intersecting twice. And these two secants are intersecting outside the circle. And what this is saying is that A plus B, that's this whole length, times A. And that's going to equal C plus D, this whole length, times just this outside part. So it's the product of the whole secant times the outside equal to the whole secant times the outside. And the last one is the intersecting tangent and secant. And so this last one says that the tangent squared is equal to the whole thing, B plus C, times the piece on the outside. Here's an equation of our circle. X minus h squared plus y minus k squared is equal to r squared, where h and k is the center. Notice the signs are opposites. This is a minus h and this is a positive h. Minus k, positive k. And r is equal to the radius, and this is r squared. When we convert from degrees to radians, we multiply by pi over 180. And when we convert from radians to degrees, we're going to be multiplying by 180 over pi. As we work through the unit, we will go back through each of these formulas and practice a lot. Let's start though with some circle vocabulary. This first vocabulary word is just circle. It is the set of all points on a plane at a set distance from a given point, which is the center. The second vocabulary, it says a segment from the center to any point on the circle. This is a radius. From the center, we'll call the center A, to this point on the circle, B, this is a radius. The next word is circumference. And this is the distance around the circle. The formula for circumference is 2 pi r, or pi times the diameter. And that is the distance all the way around the circle. An arc has 2 points on the circle and is continuous between the 2 points. So if I had this point A to B, this would be my arc. A semicircle is an arc of a circle whose endpoints are the endpoints of the diameter. So if I have my endpoints on the diameter, and the diameter of course goes through the center, and it has endpoints on the circumference, a semicircle will be half of that, half of the circumference. A minor arc is an arc of a circle whose length is less than half of the circle. This is a minor arc. And I'll give you an example. From A to C, This is an arc that is less than half the circle. A major arc is an arc of a circle whose length is more than half of the circle. So let me give you an example here. If I start with A, and then I've got C here, and then maybe D over here, this would be a major arc. A chord is a segment whose endpoints lie on the circle. Now, you can have a special chord called the diameter, or you could have a shorter chord. Both of these are examples of a chord. Let me give you some. So we can say that BA is a chord, or we can say that DA is a chord. And DA is a special chord because it is a diameter. A chord that contains the center is the diameter. Here's the center. Let's see, I didn't name it yet, so I'll call it C. And this would be a diameter. It has its endpoints on the circle, and it goes to the center. A line that intersects the circle in 2 points. This is a secant. It is a line that intersects the circle in 2 points. So if I were to extend that diameter or a chord with arrows on the end, then I would have a secant. A tangent is a line that intersects the circle at a single point. So if this is my D over here, a tangent is just going to intersect it once. The point of tangent C is the line that the point where the tangent line intersects the circle. So in the example above, it would have been D. D is the point of tangent C. A central angle is an angle whose vertex is the center of the circle. So as long as the vertex is at the center, that is your central angle. And let's see, I don't think I've labeled that one yet. This is an example of a central angle. An angle whose vertex lies on the circle is an inscribed angle. See the difference in the two? This time my vertex is not at the center, but it's on the circumference. Congruent circles are 2 circles with congruent radii. The radius of this first circle is equal to the radius of the second circle. So they are congruent. And the last vocabulary is concentric circles. And these are coplanar circles that have the same center. So if this is the center of my circle, and I had another circle inside the circle with the same center, they would be